Hey everyone, and welcome. Today we're going to tackle one of the biggest, most intimidating names in tech, Kubernetes. And to do it, we're going to totally forget about code for a little while. And instead, we're going to build a city, right from the ground up. I mean, just think about that for a second. What if, instead of getting lost in all this complex code and confusing diagrams, we could just talk about blueprints, buildings, and traffic cops? And look, I know it sounds simple, but trust me, this city metaphor, it's the thing that's going to make Kubernetes finally click for you.
Okay, so first things first. Before you can even think about building a city, you need your materials, right? Your bricks, your steel. And in our digital city, all of our stuff, or software, it has to be packed up in a totally standardized way.
And that's where the container image comes in. Think of it as the perfect universal shipping container. It honestly doesn't matter what you put inside. A website, a database, some complex AI model, it all gets packed into the exact same predictable box. That makes it super easy to move and stack anywhere you want.
So you've got all these shipping containers ready to go, but where do you keep them? Well, they need a place to be stored, and that place is the registry. You can picture it like a massive shipping port or a giant warehouse where every single one of these containers is neatly cataloged, just waiting for the call to be sent out to our city. All right, so we've got our containers all packed up with our code. Now for the fun part. It's time to actually build the city where all this stuff is going to live and run. So welcome to Kubernetes City. So in the world of Kubernetes, this whole city, the entire thing, is called the cluster. That's the boundary, the whole environment that holds everything else. Anytime you hear someone talking about their Kubernetes setup, they're really talking about their city, their cluster. But a city isn't just an empty plot of land, right? It's made of buildings. And in our city, these buildings are called nodes. Each node is basically a computer. It could be a real physical server in a data center or a virtual machine in the cloud. It's what provides all the power and space, all the resources our city needs to actually function. Okay, let's zoom in even closer. So we have buildings. What's inside the buildings? Rooms. In Kubernetes, we call a room a pod. And this is super important. The pod is the smallest, most basic unit in our entire city. It's the actual room where our container gets placed to do its job. Okay, let's just quickly put that all together because this is the foundation for everything. It's a really simple hierarchy, right? You've got the city, which is our cluster. The city is filled with buildings, which are our nodes. And inside those buildings, you have rooms, our pods. And that's where our containers actually live. Got it? City, building, room. That's the basic layout.
All right, so the foundation is laid. We have a city, we have buildings, we have rooms. But right now, it's basically a ghost town. There's nothing happening. We need to bring this place to life. So the question is, how do we actually manage all these rooms? And how do visitors find their way around?
Well, every big property needs a property manager. And in Kubernetes, that is exactly what a deployment is. You basically just tell the deployment, hey, I need 10 rooms running my website. And poof, it makes it happen. And the best part? If one of those rooms, one of those pods, suddenly crashes or breaks, the property manager doesn't panic. It just instantly builds a brand new one to replace it. It's like having automated resilience for your city. Okay, so we've got our rooms, but remember that property manager is always working, sometimes moving things around or replacing broken rooms. So how does anyone find the right one if it's always changing? You need a reception desk. In Kubernetes, that's our service. It gives you one single, stable address that never changes, and it always knows exactly which rooms are currently open for business. Super helpful. But what about people from outside the city? How do they even get to the right reception desk in the first place? Well, that is the job of the ingress. Think of it as the main gate and the traffic cop all rolled into one. It looks at every visitor who arrives, sees what they're looking for, and then perfectly directs them to the correct building's reception desk. It's the front door to your entire operation. So check it out. Our city is actually up and running. It's functional. But cities are never finished, are they? They're always evolving. So what happens when we need to renovate a building or upgrade the power grid? We have to do it safely, right? Without causing chaos for everyone living there. To really get this, let's imagine we're stepping into one of our city's top restaurants. Now, what's the #1 rule in any professional kitchen? You never, ever serve undercooked food. Well, Kubernetes has that exact same philosophy for its code. It uses these little built-in checks called probes. You can think of them like digital meat thermometers to make absolutely sure a new application is fully cooked and ready to go before a single user gets access to it. And when it comes to rolling out those updates, there are really two main strategies. The first is a rolling update. This is like swapping out dishes on a buffet, one at a time. It's slow, it's gradual, and most of your diners probably won't even notice. The other way is a blue/green deployment. Now, this is way more dramatic. It's like you build a whole new sparkling kitchen behind the scenes, and then with a single flip of a switch, you instantly direct all the diners to the new setup. Bam! Everyone gets the new version at the exact same time.
And, for those really important, maybe slightly risky updates, there's one more trick up our sleeve. The canary release. This is exactly like the old royal food taster. Before you serve the new dish to the entire kingdom, you give a small piece to a trusted taster, a tiny percentage of your users. You watch their reaction very, very closely. If everything's good, then you know it's safe to roll it out to the rest of the city.
Okay, so where are we? We've built a city that works, and we can even update it safely. But here's where the real power of Kubernetes comes in. We can turn this into a smart city, a city that can pretty much manage, heal, and observe itself without a human having to constantly intervene. And this is where the absolute magic of something called GitOps comes into play. Think of it like a smart thermostat for your whole city. You don't run around manually adjusting things, no way. You just declare in a file, this is what I want the city to look like. And then an automated controller works 24/7, constantly comparing reality to your setting. If it sees a difference, it just fixes it. It's self-healing. It's incredibly powerful. Of course, a smart city also needs to be observable. I mean, how do the city planners know what's actually happening on the streets? Well, they need citywide surveillance. Your logs are like the CCTV cameras recording every single thing that happens. Your metrics are like the energy meters on the buildings, tracking performance and how many resources are being used. And your alerts? That's the 911 emergency line. It only goes off when something is wrong right now and needs immediate attention.
So let's tie this all together. At the end of the day, what is Kubernetes? It's not just some scary piece of tech. It's a blueprint, a system for building a city for your code, a city full of containers run by automated property managers and traffic cops, and the whole thing is kept at the perfect temperature by a smart thermostat.
See, when you start to picture it like that, as a city, Kubernetes stops being so intimidating. It just becomes this incredibly powerful set of blueprints. So the only question left is, now that you can picture the city, what will you build in it?